All right, so the formula down here, of course, you need to know all of those trig formulas, and I don't expect you to know them right away because why would you, right? But you will eventually need to know them. Now, the next part that you need to know for sure is if we have a composite function, that just means I have one function plugged into the other. Then that's going to look like this, is f of g of x. Then when we do the derivative of that, we have to do the derivative of the function f times the derivative of g. So notice what that turns into. You need to be able to recognize that that formula implies the chain rule. So I would put this somewhere on my paper that is the chain rule. You definitely need to be able to recognize that. On this last AP exam, they had this written and they wanted you to calculate this for the given functions, and you had to recognize that that was the chain rule. And we'll practice some problems like that for sure. But this will be on that AP exam in several places. If you choose to repeat Cal 1 or take Cal 2, you have to know the chain rule. So this is something that's not ever going to go away. We will use chain rule all the way until May. We just do. There's always a place for us to use it. So make sure you have that. Make sure you can generate that. If you see all of this stuff, then you need to be thinking chain rule every time. Okay, is anyone still writing this? One couple of you? Okay. Most of the time, this outside function, that's going to be where we use our power rule. That's usually where that comes up, the power rule. And then we do all of our derivatizing. Okay, ready to move on? All right, so let's try these first couple of problems. Okay, y'all write down number 1. Now, sometimes students had rather take this exponent and multiply stuff out. You're not ever on the AP exam going to see an exponent of 2. It's not going to be that. It's going to be something terrible. So don't think, okay, I don't have to learn the chain rule because I can fool. In a perfect world, I would agree, but that ain't ever going to happen. So just don't even. It's not going to be successful for you. All right, so with our chain rule, and I know to use chain rule here because of this exponent. That's saying, hey, we need to use chain rule. So that's going to be a big indicator every time when you see those exponents, chain rule. Now, what we're going to do here, we have our derivative, so dy dx equals, you do the power rule first. I can't say that. Do the power rule first. So you're going to say 2 times everything inside the parentheses. So times 5x to the 4th plus 1. And then 2 minus 1 is 1, isn't it? Do y'all see how it's really the power rule of the outside stuff? Okay, so we do the power rule, and then it's times, this right here is your f prime of g of x, times the derivative of g of x. That's this stuff inside here. We need to multiply that to the derivative. So what would be the derivative of 5x to the 4th? Do y'all remember? 20x to the 3rd. And then plus 1, but what's the derivative of 1? 0. So all of that plus 0 is just 20x to the 3rd. Don't do anything else to it. Don't multiply anything. Leave it unsimplified. Leave it unsimplified. Okay? Any questions about it? All right, so let's try number 2. And I'm going to move 2 down here because it's a little easier to write. So with number 2, we have the 5th root. And so a lot of times going through this, everybody's like, well, you were talking about exponents. I don't see an exponent there. Sure, you don't see an exponent yet, Does anybody remember what that exponent might be to indicate fifth root?
1/5.
1/5, awesome. So that means that we're going to have y equals, and everything under that radical I'm going to put in parentheses. So I have negative x cubed minus 4. And I'm going to make all of that raised to the 1/5 power, because 1/5 implies that fifth root. Okay, now we repeat our process that we did in number 1. So we have dy dx equals, okay, and so our first derivative, we're going to do 1/5 times, and then everything inside the parentheses just comes down. And what is 1/5 minus 1? Negative what?
4/5.
Negative 4/5, isn't it? We groupie with that? Is that okay? And then that's your outside part. That's the power rule part. And then times the derivative of the inside. What's going to be the derivative of this inside stuff?
Negative 3x squared.
Perfect. Negative 3x squared, isn't it? Now, here's a place, though, where we're not going to be able to just leave our answers like they are. This is one place that AP really wants you to simplify, and that's going to be this negative exponent right here. They definitely want us to fix that. So let's look at, what does that negative exponent mean? Move it to the bottom, right? Do y'all remember that? So 5 is already in a denominator, right? Because it's 1/5. 5 is the denominator. So along with 5, I need to put whatever has a negative exponent with it. So when I start rewriting it, notice negative 3x squared, that has positive exponents. So I'm going to leave it in the numerator. And then in my denominator, I have 5 times, and then I'm going to move that has the negative exponent to the denominator and make the exponent positive. So we have x cubed minus 4, and then that's going to be raised to the positive 4/5. And you leave it alone. But that negative exponent is the only thing you ever have to adjust. Don't try to move anything else. Okay? Questions about it? All right, so let's try another example. Okay, let's look at number 3. Okay, so what rule does it look like we're going to have to use here? Now look at that. We definitely chain rule because we see this. There's another rule, though, that we need. What do y'all think? So we have this. That's going to be chain rule. What's happening with what's inside the parentheses and that radical? Are they adding each other? Multiplying. So if you're multiplying, you also need the product rule. So we're going to do the product and chain rule together here. So you have both rules that you're going to have to use. Okay, I would go ahead and rewrite. So I have f of x equals, and I have all of this stuff inside the parentheses. And then I'm going to change this x plus 1 to be raised to what power? What power would mean cube root?
1/3.
1/3, awesome. Okay, so let's talk about that product rule. Do y'all see why I'm doing the product rule? You've got two things multiplied together there, right? Okay, so let's go ahead and start. We have f prime at x equals. So it's going to be the first, which is this right here. So we have 4x to the 5th minus 1. So we have first times the derivative of the second. Now when I do the derivative of the second, I've got to have the chain rule because of that exponent there. So let's see, if we do derivative of the second, we're going to have 1/3, and I'm going to do parentheses. I have 1/3 times x plus 1, and I need to say 1/3 minus 1, which is going to be what? Negative 2/3, isn't it? Okay. And then don't forget, we've got to say times the derivative of the inside. What's the derivative of the inside? Not 0. Well, one of it's 0, but 0 plus 1, which is 1. Okay, so let's talk about those steps again. So we have first times the derivative of the second, and the second had to have chain rule. Okay, and then we're going to say plus the second, which is x plus 1, all raised to the 1/3, plus the second times what? Perfect, derivative of the first. Do I need chain rule with the derivative of the first one? No, there's no exponent sitting outside that other than a positive 1. So what would that derivative be?
20x to the 4.
Perfect. Okay, now let's look. Do I need to simplify anything here? Let's investigate. What's the one thing we have to go look for?
The negative exponent.
Negative exponent. That does need to be flipped. So let's look at what we would write. We have f prime at x equals, and let's see, right here, that's where the negative exponent is. And notice 3 is already in the denominator, right? It's 1/3. So my numerator is 1 times 4x to the 5th minus 1, which is 4x to the 5th minus 1, over 3, and then times x plus 1 to the positive 2/3 because I've moved it. And then plus, and then over here, that stays x plus 1 raised to the 1/3. It's not negative, so don't move it. And then times 20x to the 4th. Okay. All right, so I'm going to move it down here. So let's see, when you rewrote it, you have a y prime. I'm going to change it to f of x. Okay, so negative x to the 4th minus 1 is raised to what power? 1/2, isn't it? Did y'all get that? Yeah. Times, and that's what? Negative x minus 2, right? Okay, so f prime, what rule do you need here? There's 2 of them. Chain rule, product rule. So let's do the first. Do I need to do chain rule yet? So there's the first times the derivative of the second. What's the derivative of the second?
1.
Negative 1, isn't it? So first times the derivative of the second plus, okay, what about the second? First, derivative of the second.
Second derivative.
Second times the derivative of the first. So we're going to do the second one. Let's see, what's the second one? Negative x minus 2 times the derivative of the first. So we need chain rule here, right? So it's going to be 1/2 times negative x to the 4th minus 1 to what power? Negative 1/2. Is that all right, all right, all right? And then times the derivative of the inside. What's going to be the derivative of the inside? Negative what? Y'all are quiet on me. Negative what? Right here, negative 4x cubed. Okay, questions about that? Y'all look at it. Okay, what do I need to adjust? What will need to be moved? All right, so we have f prime at x equals, I won't adjust anything really in this first part, so we can either bring it down. Now, you're welcome to put that negative in front if you want to. It really doesn't matter. Just don't try to move the negative to the inside of the parentheses because that's raised to the 1/2 power. And then plus, and it looks like my numerator is going to be negative x minus 2 times what? Negative 4x cubed. Does that look right? That's my numerator. And then what's in the denominator? We have a 2, don't we? And then we have negative x to the fourth minus 1 to the positive 1/2. And would I do anything else with that mess? No, wouldn't do anything else with it. Questions about it? Any questions? Okay, let's see now what they give us. Okay, y'all try those two. Okay, so for 5, we're going to do, let's see, y prime equals, and we have the first times the derivative of the second. So let's see, gosh, that's where I need the chain rule, isn't it? So I'm going to have negative 3 times negative 3x squared minus 4 raised to what power? Negative 4, isn't it? Because you minus 1. And then times all of the derivative of the inside. What's the derivative of this inside going to be? Negative 6x. Perfect. Is that okay? Nope. All right, let's erase it and do it again.
Wait, don't erase.
Oh.
You have to erase.
Well, I don't care.
I didn't get the negative 6x, and I don't know. Because are we doing the first times the derivative of the
Second, yes. And then the derivative of the second is chain rule.
Where did you get the negative 6x?
The derivative of the inside part.
Oh.
Because you do your power rule, so that's where the negative 3 and negative 4 came from. But you don't do anything with the inside stuff. And so the next step to that would be do the derivative of the inside stuff. Is that okay? Please ask. Yes, sir.
Where did the negative 4x come from? That's just what's...
The negative what?
The 4x.
So I did the same thing, so I thought
It's
that's
just
what-
negative 3 minus 1? The x.
Where you get the
Oh,
negative
yeah,
four
that's
x
where you get the
from.
negative.
The x factor.
Then you're saying numbers aren't even
Let's talk about the negative.
I know. Okay, that's where I was like, I don't know. Do you see? Did y'all figure it out? Okay. Annabeth, I'll get you caught up since y'all come in a little bit late. It's fine. I'll get you caught up. Okay. Yeah. Those of you who came in late, I'll get you caught up. Don't worry about
I
it.
just don't know where the negative fourth power came
Negative 4, because how do I do a derivative? I subtract 1, right?
from. Right.
So what's negative 3 minus 1?
Okay. I understand
Both.
how to do it.
Got it? Okay. Got it? Good.
Anytime you have a negative exponent, you're gonna want your own one.
Yeah.
Negative 1.
It'll end up
So if
combining.
it was to the second power, then it would just be
1. Yep.
But
Y'all
one,
good?
like,
Okay.
That 3x squared minus 4, you take the exponent, multiply it. It's like the same thing.
Right. That's the chain rule, and that's the part y'all miss because you've got a function inside of a function. So just do your power rule and then derivatize the inside.
And then you multiply it.
Yep. Okay, so now we have first times the derivative of the second plus the second, which was what, negative 3x squared, right? Minus 4 to the negative 3, right? Second times the derivative of the first. What's the derivative of the first? Just 3. Okay, so here's the first. Let me get my little lightsaber out here. So, boom, boom, boom. First, yeah, derivative of the second. All this inside that bracket is the derivative of the second because of the chain rule.
Do you have to bracket it?
I don't care. Plus second times the derivative of the first. And now we need to, the only thing that they're picky about, negative exponents, right? So let's look and see what have we got here. Y prime equals, so we know 3x minus 1 doesn't have a negative exponent, so it stays where it's at. Negative 3 doesn't have a negative exponent. What else doesn't? Negative 6x doesn't. And then what goes to the bottom? Whatever has the negative exponent, which is negative 3x squared minus 4 raised to the positive 4 now. Plus, okay, and over here 3 doesn't have a negative exponent, so it stays where it's at. Negative 3x squared minus 4, and it's now raised to the positive 3. Okay. All right, y'all look at 5. It's messy. I know. We take a little while on chain rule. It takes a bit.
When do you know when the chain rule goes into play?
Whenever you have that exponent sitting there. That exponent's what's telling me.
So it's just used to find the derivative when you're simplifying.
Yes. Yes.
So if there's an exponent.
You know you're going to have, if you've got plus or minus stuff, parentheses, exponent, chain rule every time.
Okay.
Every time.
And it's just the odds of the
Yes.
one with.
Yeah.
So
Yeah.
like on the second one.
We're going to, let's talk about that
I know
one.
number 6, like on the second part, like
Yeah.
the plus. Because you didn't have to do the derivative of the one with the exponent, you didn't have to do the chain rule.
Right.
Okay.
Perfect. Very good. Yeah. All right, so number 6. Let's talk about how to rewrite number 6 because you have a couple of options. One thing, don't multiply that crap out. That's craziness. Just don't. All right, so for number 6, we do have f of x equals one option, and this is usually the option students choose, but again, I don't care. You pick whichever way you feel comfortable with doing, as comfortable as possible with this mess. So you have 5x to the 5th minus 3. Since this is in parentheses, it's all raised to the 3rd power. That implies both the numerator and denominator. So I know this first part's raised to the 3rd. And we can either do the quotient rule, which kids try to stay clear of because of the signs. So the other option would be for us to say, and that's also multiplied to negative 3x cubed plus 1 raised to the negative 3. Because it was on the denominator, I want to flip it over to the top so I can just deal with the product rule and chain rule. Okay? All right, so y'all try that one. All right, so we're going to have f prime at x equals, and we're going to do the first times the derivative of the second, and the second's going to be chain rule. So I'm going to have negative 3 times negative 3x cubed plus 1 to the negative 4, right? Because we subtract 1 times the derivative of the inside, which is going to be negative. Okay. Is that okay?
Yes.
So first, derivative of the second plus the second. So we have negative 3x cubed plus 1. Bless you. Oh, I bumped. Plus 1 to the what? Negative 3. Right? Yes.
Right, where does that negative 3 come from?
This negative 3 right here,
That one.
that's going to be your power rule. Because whenever I do the derivative of the second, we have to do the chain rule. And so the chain rule, the first step would be just the power rule of this.
So you just put it front,
Put it in front, subtract 1 from your exponent.
and just stays there.
And it stays there. And then the derivative of the inside is what's going on over here. It's what you multiply by. Okay, so let's see, we've got the second times the derivative of the first. Derivative of the first is going to be 3 times 5x to the 5th minus 3 all raised to the second times the derivative of the inside. What's the derivative of the inside? 25x to the 4th.
Well, I'm confused. Why did you just do that on the second? Is it because there's a negative exponent?
Because there's an
On the other
exponent.
one, we didn't do that though.
Like on number 5,
Yeah, like on number 5 on the second.
this one didn't have an exponent, so there wasn't a need for it.
Okay, now I get it.
Okay, got it? Good questions. All right, and then let's clear this up. Move your negative exponents. Let's make sure we did that right. Okay, so first parentheses, 5x to the 5th minus 3. Do I have a negative exponent there? No. What about negative 3 out here? No.
Negative 9x squared.
Negative 9x squared. Negative exponent goes to the bottom, so we have negative 3x cubed plus 1 raised to the positive 4. Now, if you keep it negative when you move it to the bottom, it'll be marked wrong. Plus, over here, it looks like we have what? 3 times 5x to the 5th minus 3 all squared. Is that still in the numerator? Yeah. Okay. That's numerator. What else is up there? 25 x to the who? 4. Yeah? Good? Awesome, awesome. And then what's in my denominator? Negative 3x to the 3rd plus 1 raised to the positive 3. Did y'all get it? Success? Woo! Awesome. Questions? Questions? Please ask. Got it? Good. Yes, sir.
Is there anything longer than this?
I can't hear you.
Is there anything longer than this?
No, this is about it. No. Y'all are doing the hardest part of the derivatives. All right? Good? Got it? Awesome. Now let's throw in some trig with it. Okay, so y'all go flip. Now, the trig part, actually kids find the trig easier because there's not so many x's and numbers. Okay, so y'all on your little fold, you remember your little flip book, go find your trig. Okay, now let's do our trig. When you start seeing the trig stuff, you're like, oh, that's so much easier than what we just did. And it is. Okay. Y'all go find your trig stuff. So now we're doing all the derivatives. And this is thrown into the chain rule part because you actually have to use the chain rule to get the derivative of this angle here. Because you'll do the derivative of the trig function and include the angle given, and then all that's times the derivative of the angle. And so it's really a chain rule there. So the first thing we need to remember would be the derivative of sine. Okay, and at one of the study sessions, I can't remember, I think it was 2 years ago, the teacher that was presenting said that she tells her, it was he said he lists SC, negative S, negative C. And that's how your derivatives go. Your derivative of sine is cosine, derivative of cosine's negative sine, derivative of negative sine is negative cosine, and then it just wraps around and it just repeats itself over and over. So SC, negative S, negative C, some people found that helpful. It's up to you. I always remember if I'm doing the derivative of anything that starts with a C, it's going to be negative. That's it. If you do the derivative of anything that starts with a C, any trig function starting with a C, it's going to be negative every time. Okay, so let's see if we can't figure out f prime of x for this one. Well, we start out with what is the derivative of sine? Derivative of sine is cosine. So we're going to say cosine of the angle. So derivative of sine of the angle is cosine of that angle. So still 2x cubed. And then it's times the derivative of the angle. What's the derivative of 2x cubed? 6x squared. And you're finished. Oh, right. Do y'all see why I say, okay, the trig functions are really a little bit easier? That's it. All right. So let's go look at number 2. And I'm going to pull that down here because I keep hitting the menu options over here. So we have y equals tangent 5x cubed. Okay, so y'all go look for me. What's the derivative of tangent of an angle? Secant squared of that same angle. 5x cubed, right? Do y'all see that derivative of tangent of an angle is secant squared of that angle? And then it's times the derivative of that particular angle. Well, what's the derivative of 5x cubed?
15x squared.
Perfect. Bam.
Okay.
Okay? Yes. Trig functions are... All right, let's move on to the next. Y'all got it? Okay. So, y'all try those two. Okay, so let's see. For number 3, we have y prime equals, and what's the derivative of secant of an angle? It is secant. All right, secant of the angle times tangent of the angle, right? And then what else have I got to multiply by? Derivative of the angle itself. And what's that derivative? 20x to the 4th. Great. Questions about it? Okay, so number 4, the derivative there, y prime. Well, the derivative of cosecant is going to be negative because it's c. I know that much, right? And it's going to be negative what? Cosecant, CSC, right? 5x to the 5th, right? Times cotangent, 5x to the 5th, times 25 x to the 4th. All right? Did y'all get those?
Yes.
Good? All right, last set of examples. Last one. Well, I lied. There's 2 more. Okay, now let's just look at them. What rules am I going to have to use here? Let's look at number 5. We've got this times this. So that's the product. So I'm going to have to do the product rule, right? Okay, so y'all give that a whirl. See what you can do. So let's check. Y prime equals first 2x to the 5th plus 3 times derivative of the second, derivative of cosine, negative sine x squared, right? Times, what's the derivative of x squared? 2x. So there's first times the derivative of the second plus the second, which is what? Cosine x squared times the derivative of the first. What's the derivative of the first? 10x to the 4th. Do I have any negative exponents here? No. So leave that mess alone. Don't do anything else to it. Leave it alone. Is that okay? Questions? All right, so number 6, we're going to have to do the quotient rule. So y prime equals, let's see, quotient rule was the bottom, which is cosine of what, 2x cubed? Okay, so bottom times the derivative of the top. What's the derivative of the top? Negative, looks like 4x. Is that right? Yeah. So bottom times derivative of the top minus. Okay, and then top, so negative 2x squared minus 5 times the derivative of the bottom. Derivative of cosine's negative sine, isn't it? So negative sine 2x cubed times what? 6x squared, right? Okay, so, and let's see, is there anything else with the quotient rule? All over, oh, it's got a denominator to it. Uh-oh. It's all over. Does anybody remember? It's the bottom squared. So it's going to be what? Cosine 2x cubed. All of that squared. Do not try to square that angle. That is not ever going to be true. So it's bottom times the derivative of the top minus the top times derivative of the bottom all over the bottom squared. Okay, questions? All right, last slide. This time I promise this is the last slide. And don't worry about, well, yeah, we need to do both of these because they're funky little problems here. Now, number 7, do y'all recognize what might be different about that one? The sine is cubed. When the trig function is cubed, crap happens, and we need to look at what that crap is. I'm sorry. Awesome mathematical things appear with this problem when the trig function has an exponent other than 1. No, not any better, is it? All right, after you get 7 written, we will rewrite it. Yay. So I'm going to rewrite this little booger. And I'm going to move that exponent to the outside so that this says sine x to the 5th all cubed. Do that every stinking cotton picking time. That will help you every time. Because now we see that that exponent is on the outside of the parentheses. Ding, 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 chain rule. Chain rule upon chain rule. So, everybody got this on their paper? Let's start chain ruling it. F prime at x equals, we have to address this power rule business first. So that's going to be 3 parentheses sine x to the 5th all squared. Y'all see how that's the outside? Power rule outside. Now start derivatizing the inside. What's the derivative of sine of that angle? It's going to be cosine of the angle times what? The derivative of the angle. What's the derivative of the angle? 5x to the 4th. Look at that mess. Now you're finished with it. Look at what happened when the exponent was on the trig function. Okay? A lot of stuff had to happen there. That's true every time. Every time. So instead of doing number 8, let's make up our own number 8. Let's practice that again. Okay, so we're going to have f of x equals, and let's do cosine raised to the 4th power, and then my angle is going to be 3x cubed. Okay. And again, I would start out by rewriting it to be cosine of 3x cubed, and then move that 4 to the outside. Now you're ready for the derivative. So first part, deal with that power rule first. So it's going to be 4 cosine 3x cubed raised to the 3rd. Power rule first, get that out of the way. Times the derivative of cosine is going to be negative sine of that angle. And what's the last thing I need to multiply by? Derivative of the angle. What's the derivative of the angle? 9x squared.